Okay, so for our next problem on rhombuses and squares, this is our sixth lesson for the second quarter. Okay, we have here in the diagram below the intersection of diagonals the intersection of diagonals of the squares A, B, C, D, and E, F, G, H shares the same point O. So they have the same point of intersection O at the center. What is the perimeter of trapezium ABFE? So where is ABFE? Let's try to draw it. Okay, let's try to draw it using a different color. So there's A, B, F, and E. There you go. Okay, so what's the perimeter of that trapezoid, or that trapezium? Okay, so how do we find the perimeter of that trapezoid? Okay, we have two clues. First clue being that the perimeter of ABCD is equal to 120. Now, if that's the only given that we have, we won't be able to solve this problem. We will be able to get the side measurements, so that's 120 divided by 4, and that should give you 30, but that won't be enough in order for us to find the value of EF for this problem, or AE or BF. And if we're just going to be given the perimeter of EFGH, which is 40, yes, we'll be able to solve for EF, but we won't be able to solve for AB, AE, and BF. So we'll need to combine these two evidences, these two given information that we have, in order to solve for the perimeter of trapezium ABFE. So how are we going to solve this? So for the first part, since both of them are squares, okay, ABCD is a square, and EFGH is also a square, let's try to find their side measurements. So for the first one, the bigger square, so that's going to give us 4s is equal to 120, and for the second square, so that's 4s is equal to 40. Dividing both sides by 4, so therefore the side measurement of the bigger square is equal to 30, and the side measurement of the second square, or the smaller square, is equal to 10. So this should be 30, and this should be 10. There we go. Okay, so we already know the bases of our trapezoid, or our trapezium. So B sub 1 is equal to 30 units, and B sub 2 is equal to 10. It's equal to 10 units. Okay, so we just need to find AE, and BF to get, or to find, the perimeter of ABFE. ABFE perimeter. So how will we do that? Okay, so in a square, there is a diagonal. Okay, we always find diagonals in a square. And that diagonal is always equal to the side measurement multiplied by the square root of 2. Now, if the side measurement is equal to 30, and we multiply that by the square root of 2, that's going to be the value of AC. So AC is equal to 30 square root of 2. That's also the same case with EG. So since EG is equal, EG is the diagonal of the small square, and EF is equal to 10, and FG is equal to 10, we can say that the diagonal, so this is D sub 1, D sub 2 is going to be equal to S square root of 2, so that should give us 10 square root of 2. There you go. Okay, now if this is 10 square root of 2, okay, so since we know that AC is equal to 30 square root of 2, and we know that EG is equal to 10 square root of 2, this diagonal over here, and we know that AC is equal to AE plus EG plus GC. And since this square is at the center of the circle, we can say that AE is equal to GC. Okay? So both of these side measurements are just congruent. They're the same. So therefore, we can say that AC is equal to AE plus EG plus AE, and therefore AC is equal to 2AE plus EG for this problem. We already know the value of AC, so that's 30 square root of 2. And we already know the value of EG. Okay, the value of EG is equal to 10 square root of 2 for this problem. So to solve for AE, that's going to give us 30 square root of 2 minus 10 square root of 2 is equal to twice of AE, and subtracting these two square roots. So we have, or these two terms, we will have 20 square root of 2 is equal to 2AE. And if we divide both sides by 2, we will get the value of AE. AE is actually equal to 10 square root of 2 for this problem. Okay, so that means the measurement of this side over here, okay, so that's 10 square root of 2. Okay, now if that's 10 square root of 2, most likely this is also 10 square root of 2, since the inner square is at the center of the bigger square. So that means the perimeter of trapezoid ABFE is going to be equal to AB plus EF plus AE plus BF. And since we know the value of AB is just equal to 30, EF is just equal to 10, and AE is equal to 10 square root of 2. So that's 10 square root of 2, and BF is also the same. So let's compute. So this is going to give us 40 plus 20 square root of 2. So therefore the perimeter of trapezium ABFE is just equal to 40 plus 20 square root of 2 units. There. If you're going to try to simplify that using your calculator, so that's 40 plus 20 square root of 2. Okay, 40 plus 20 square root of 2. So that should give us approximately 68.28. So therefore the perimeter is approximately 68.28 units. And that's how we can solve this problem. The perimeter of our trapezoid of trapezium ABFE is approximately 68.28 units, or 40 plus 20 square root of 2 units.